Okay, now we're still going to talk about graphing, but this is going back to the transformation rules, same transformation rules that you've learned in the past, but of course these are specifically applied to the exponential functions. So like I've written it, specifically using what an exponential looks like. So I've just used a B, of course, to stand for the base, which that will vary from problem to problem. It may be that you're graphing a base 3, you may be graphing a base of 1/2. But in order to have the transformation, the horizontal shift, the left or the right, the number that's added or subtracted is going to have to be in the exponent. So if you remember in the past, I've always stressed about the horizontal shift is always in the function. So if you're going to be in this particular type of function, you're going to be in the exponent. Now with the vertical shift, the up or the down, you can see the number that's added or subtracted here comes completely after this exponential function. So this will be at the end of it. Of course, the negatives, negative in front's x-axis, negative in the function is going to be y-axis. Stretch or shrink, of course this is the vertical stretch or shrink, then you would have a number in front of the base that's being multiplied. So these are both representing numbers. So you could have a 5 here and have a 2 here. So like 5 times 2 to the x. So if a number's multiplied times that exponential, that's where your stretch or your shrink comes in. Alright, so the first one that we're going to look at. Now you notice that this one that I'm going to graph as my example is a base of 3. So I graphed y equal 3 to the x a few minutes ago. So I want to be referring back to that graph because that's like my parent graph to help me do my transformation here. Now the transformation that you have for this particular example is a y-axis reflection. See, your negative is in the function, it's in the exponent. So we have a y-axis reflection. Now that's the only transformation that this particular graph has. Okay, so I'm going to pull back in here just a second. This is where we had graphed earlier y equal 3 to the x. So I'm using this as my starting point. And what I would suggest is that we just use these 3 points here. And I know this one's not a nice little whole number, so that's the -1 1/3, but we'll be able to figure it out without any trouble. So I'm going to start out by plotting these 3 points. That's my starting spot. Okay, so I had the point 1 3, 0 1, and -1 1/3. And now I have to take those points and do the y-axis reflection. Okay, so this point being on the right side, if you reflect it about the y-axis, it's going to come over to the left side. So it'll be lined up now with x equal -1. This point is not going to move. I mean, that's right there on your pivot point when you're doing your reflection. This one that's on the left side will now reflect and be over here on the right hand side. So this ends up being my final graph. So there's your y equal 3 to the -x. Okay, next one we're going to look at. But I'm still going back to the same basic graph because again my base is 3. So I'm going to use those same 3 points that I started with just a few minutes ago. Alright, the transformations that I have here. Having the +4 in the exponent, that tells you that your graph is going to go to the left 4. And then having the -2 there after the exponential tells us that our graph is going to go down 2. Okay, so I'm going to put in the 3 points that I used just a few minutes ago. So this is going to be the point 1, 3, 0, 1, negative 1, 1/3. Alright, so my first step that I need to take would be to go to the left 4. So starting with this point, and now this point, left 4, and now this one. Okay, now I'm not going to connect those up because I still have one more transformation that I've got to go, because now I've got to shift each one of those down 2. Okay, so I'll start with this one and go down 2, which is going to put it just a little bit above the negative 2. You see how it's a little bit above the x-axis here, so then 1 unit would be a little bit above the negative 1, so this one would be a little bit above the negative 2. Okay, and then this one down 2, and now finally this one down 2. Now, I didn't mention this a while ago because it wasn't anything that changed about having the y-axis reflection. But if you remember, like going back to the original function, like if I were to connect up my original points, I would have to come here and level it off along the x-axis. But this graph having the transformation where it shifts all the points down, that asymptote is going to shift with it. Now, the first transformation going left, I mean, if I take my x-axis and I move it to the left, it's still in the same spot. So that transformation didn't affect it. It's coming down that affects it. So what I would suggest that you do is actually dot in, you know how we'd always dot in asymptotes, is where it was here at the x-axis. Like I said, it also comes down too, just like all these points came down to. Dot it in, and that way you'll know exactly where it is that you have to level your graph off. Because when you're graphing these, you can't level it off at the wrong spot.